Okay, so solar power question. We have a cell of area 6.5 times 10 to the minus 4. Oops, that was a bit big. That's better. It's situated on the roof of a house. The cell has an efficiency of 8%. So that's your efficiency. And at a time when the power of the solar radiation is at a maximum, the cell delivers 47 milliwatts. So that's times 10 to the minus 3 to the external circuit. So deduce the maximum value of the power of the solar radiation incident on the cell. So basically what it's saying is that your solar cell is giving off 47 times 10 to the minus 3. It's only 8% efficient. So how much is it receiving? And it's a simple efficiency question because you have your energy out and you need to work out your energy in. If we use the efficiency formula relationship, it's quite straightforward. We substitute our value of energy out, 47 times 10 to the minus 3, and your energy in, we can calculate by finding or by using the formula. Now, it's not the end, because the answer that they give you, they deduce the maximum value of power incident on that the incident power is 0.9 kilowatts per square meter. This question's a bit misleading because what they're actually giving you is the intensity. It's per square meter. So once you work out the power, which should be 0.58, that's what you get as your energy in watts. You then work out the intensity, you divide it by the total area, which is 6.5 times 10 to the minus 4. That will give you the power per square meter. And that will give you your answer of 0.9, which is a bit of an odd one, 0.9 kilowatts. Could have just said 900 watts, but anyway, that's how you work it out. So in this question, what we've got is a power of 3 kilowatts, 3 times 10 to the 3, is required to produce hot water for the house. Use data from B to determine the minimum area of photovoltaic cells used to generate this power. Okay, so if we have a look at the information that we already have, 6.5 times 10 to the minus 4 square meters is needed to give you how much energy? 47 times 10 to the minus 3. So if you have a panel which is 6.5 times 10 to the minus 4 in size, it will give you this amount of energy. So now we need to know how big does it have to be in order to give us the required amount, which is 3 times 10 to the 3. That's minus. Now, it is as easy as it looks. It's one of those famous rule of 3 questions. So if you divide the actual power that you need by the power that 1 gives you, so 3 times 10 to the 3 divided by 47 times 10 to the minus 3, and then you multiply it by the area of 1, you should get your answer. Okay, so note that things have changed now. We're talking about an active solar heater, no longer talking about photovoltaic cells. The efficiency of energy conversion in an active solar heater is 24%, way bigger than the 8% for the photovoltaic cells. Note, calculate the minimum area of the solar heater. Now, what it's asking you is, if we get a certain amount of energy from the sun and it falls on our solar heater with 24% efficiency, how can we get 3 times 10 to the 3? So how much do we get? We get 0.9 times 10 to the 3 watts per square meter. So the total energy that we're getting, let's have a look. Energy out versus energy in equals, well, the energy out we're getting is 3 times 10 to the 3. The energy in is 0.9 times 10 to the 3, but that's per square meter. So you need to multiply it by this X number. What was X? The size, the number of square meters that you need, right? So that will give you 0.24. So if you rearrange, you should get 14 meters squared. Now, what's tricky about this question is it's shifting. It's quickly gone from photovoltaic cells to a solar heater. And that's that question done.